I'm Jeff Potma, Vice President of Structural Heart at Medtronic, and it's my extreme pleasure today to spend a few minutes with Eberhard Gruber, who's been a pioneer within coronary and structural heart for, I would say, Eberhard for a couple of decades, but that dates us a little bit much. And it's a real pleasure to talk with Eberhard about where we're heading with our structural heart pipeline. It's almost very, very impossible to even imagine in 2006 when we were first seeing the data out of the legacy CoreValve Classic with its superannular design, its porcine pericardial leaflets, its canting of the leaflets to enhance durability. And what's happened since 2006 has truly been remarkable, both respect to collection of clinical data from our extreme and high and intermediate and low risk clinical trials, but more importantly to the evolution of the transcatheter designs that we embedded into these clinical trials, from CoreValve to EVOLUT Pro and EVOLUT Pro Plus. Yeah, I think one of the things that we've really learned about the durability data, particularly with Lars's Notion 8-year presentation, is that the gradients held up, and that seems, at least in our opinion, to have translated into superior valve durability compared to surgery, which is important. But you've noticed the two things that we've really had to focus on, and one is pacemakers, and I think we've been able to get that rate down substantially with our cusp overlaps. There are a lot of discussions at EuroPCR 21 about that. Secondly is coronary access, a very, very important issue, and we learned now that we really need to align the commissures better, which we can do by entering the flush port at 3 o'clock and have good coronary access. But our whole future program, as we'll talk about, is going to be related to aligning commissures. Can you just reflect for just a second about how you think commissure alignment will be important, not just for this valve, but for all valves?
Very important point, Jeff. And remember, I remember there was an investigator meeting when Jean-Claude was there and you were leading this, how important that was. How do we load the valve? I mean, to be honest, at that time, we were more focused on outcomes and on other things. But nevertheless, it was an important issue. And that is coming back now because the focus of the valves have changed. Coronary access is a very, very important aspect of today's world. And the commissure alignment is not only something important for CoreValve, it's basically important for all the valves, because not all valves are positioned ideally. And in order to get through the leaflets, you have to do commissure alignment. And the fairly easy, instead of looking at loading and how you load, you have the tabs on top of the valve, the two, and you have the flush port. It gives operators a guide on how to implant the valve, not with the spine, and you have to be at the outer curvature and this and that and this. People don't think and didn't think about this a lot. Now it is important because we want and need coronary access as we move not only in lower risks, but potentially younger patients. And therefore, that is absolutely crucial. And you show this slide beautifully on how to do this. Easy, port at 3 o'clock, and then move. So you have a very, very high probability, and we owe this to Tang, that this is being not only published, but this is being followed through. People are just paying more attention to it now. And that's why I think it is absolutely crucial and beautifully done by the proctoring service and by you.
So let's go to the final question, right? Which is the final thing about valve and how we do that. And you did a spectacular case at GYM illustrating in a very elderly patient, not only that you could do the valve, but you could do a mitral clip and then repair the tricuspid valve as well. It was amazing. Can you speak to what some of our options for treatment in the rare event, but real event that the CoreValve or EVOLUT would fail?
Well, I think, Jeff, and thank you for that question, because let's be honest, we would expect any bioprosthetic valve, regardless of branding, degenerate at some point in time. Now, there are some specifics about each individual valve and not only self-expanding versus balloon expandable, but also the design, the cell size, the size of the valve itself. So there are differences, and there have been different opinions. And there has been also an evolution of this process, and you were almost instrumental on how this could be done in an intelligent way. And by intelligent, I don't mean by intuition, but also, let alone the branding, saying, you know, we have a core valve here now, and now we have to use another core valve in order to stay within the line, instead of using an approach that makes more sense. Basically, what has been done was, if one valve degenerates, in this particular case, the EVOLUT had generated after 10 years, which is an okay. The lady got it 2009, so 11 years almost, degenerated. Now the question is, how do we correct that? And in order not to have the tunnel supravalvular on supravalvular, you know, we decided, you and I, actually, on a long discussion, it makes more sense to take a sapien valve, an S3 in this case, for the reason of coronary access, particularly coronary access. It is on label, so we were all in line with what's recommended. And I think it makes sense, once you have a degenerated valve, to try to intelligently approach it. And here you see the sapien 3 very easily passed with the catheter into the coronaries. And that's what we really need to get access into the coronaries after valve and valve. And we will have that, obviously, that problem as we move into younger ages.
Yeah, and we're working on a lot of preclinical work to show this and plan it out in case planning. So as a proctor, we'll be talking about that a lot. So let's just talk about the future for just a second. And you know, we've got a portfolio of places we can go. I will say that our next generation of catheters are going to be thinking a lot about commissural alignment, but there's a lot of other adjunct technologies, TAVI or accessors we call them, that we can move toward. Can you just pick one or two out of these that you think is going to be like good for us to focus on?
The wire situation was a very important step. Now we have two preformed wires. That was an important step in order to get away from the perforations. Number one. Cusp overlap, very important, because we looked at probably the wrong way at the membranous septum. So this is not transformational, but this is extremely important to get the pacemaker rate down. Lifetime management, coronary access, we just talked about. Embolic protection is going to be answered by the PROTECT TAVI trial. We will have that answer. I know you're sitting on watch and you do a watchful waiting on that. Temporary pacing, I said it from day one, Jeff. Medtronic is the company, the pacemaker company, that could have addressed that maybe a little bit earlier. I think it is an important issue. We know that the minority of patients need lifetime pacemakers after implant. That is a transitional time, and you call it temporary pacing versus long-term pacing. I think this is an important issue, which I'm sure Medtronic will settle and resolve with their plans. But for me, the leaflet management is something of specific interest, because we will see this more as we go along with degeneration of those valves and the previously implanted surgical valves. So leaflet management, quote unquote, is something very important. And I think what you indicated here is for the TAF and TAF situation, for the bicuspid situation, a very important aspect. Personally, my favorite for the time being anyway. And I think we will see more and more of these devices. And I know that you're sitting tight on this development.
All right, well, let's thank you for that, and let's just swap over to mitral for just a second. And I know we're all excited about the mitral program and what it's going to really mean for patients. As you know, there have been toolbox approaches that we've had within the structural arena, and very effective edge-to-edge repair devices, working on annuloplasty, choroidal repair. Replacement has been a theme, and we'll also talk very briefly about some repair ideas that we had. But can we speak to just a second about Intrepid? You know, as we know, we're shifting Apollo in the United States to be evaluated in two populations. One is in MAC, and the second is in those patients who are not surgical candidates and also not suitable for a clip. And that's going to be for TA. But then we're also in the middle of now our early feasibility study with the TF approach. So maybe you can speak for just a second, Eberhard, about the unique design that we have and how that might apply to patients.
Yeah, I mean, obviously, if we talk about the mitral space, you know, a company for the sake of the patients, for the disease entities, have to be ready to offer a valve and to offer some kind of repair, whatever that you might call that. But here, the design has been very different from other designs in that you have a conformable outer stand that compensates for the motion, three-dimensional motion of the atrium, and compensates for that, basically leaving the inner valve, the circular inner stand houses, which is a 27 millimeter tri-leaflet bovine valve, alone. So it doesn't, the transformational motion will be buffered, if you wish, by the outer stand, and the inner stand is being left alone in terms of deformation.
You know, we have really good edge-to-edge repair devices, right? With Gen 4 MitraClip and with Pascal, and those are very effective edge-to-edge repair devices. And so to enter into that market for us is a little tricky. So we've tried to come up with a different concept of how we might do repair, and we're working with Half Moon. It's not in our portfolio yet, but we have an investment within Half Moon for a very unique repair device. And I know you have some familiarity with this, Eberhard. Do you want to kind of walk through this and say why this might have value as a repair adjunct to our replacement technology?
Jeff, I'm very grateful that you are my partner in this interview. And we know, how did we start out on TAVR? We said, if the results that we're trying to achieve non-invasively or less invasively is equal or better to surgical results, then non-invasive or less invasive will reign supreme. And let's be honest, on the mitral journey, we have simply not achieved that level of efficacy and safety yet. So we have to think a little bit out of the box. And the clip device is something that was important, successful so far. But there are some drawbacks, not only the patients that are considered to be unclippable, and that is also a moving target depending on inclusion criteria, depending on operator experience. But the clip is a clip, and it kind of reduces or limits future options. You have to either take the clip out if the clip patients come back, or you have to apply some kind of annuloplasty device, which until now at least has not been very successful in the portfolio of any company. So even though the trial, the COAP trial, and the follow-up is very important, I think we have to think a little bit out of the box. And this is, to me, extremely appealing. Not only would, if you follow the clip way now, you would be number 3 on the market, which takes years. You're approaching it, I think, together with Half Moon, and thinking differently. And that is out of the box, and I think that is what we need.
Well, Eberhard, this was just a brilliant interview. I got to say, I've just been so impressed with your contributions that you provided to all of the structural space over the years. And I really have to say, we're very, very thankful to have you as a partner moving forward, because really, as long as we keep thinking about the patients and what we can do to help them, we'll be able to come up with designs of new devices that will be able to address those needs. So from EuroPCR 2021, Eberhard, thank you for a wonderful time this morning, and we look forward to many, many more sessions about the future of structural cardiology in the future. Thank you.
Thank you very much, Jeff, and thanks, Medtronic, for having me in this interview. Thank you and good luck.